And welcome! It is Lara at the library again, and I am here for another STEAM Studio video. So today we're going to be working on creating our very own heatless lava lamp using the concepts of polarity, density, and a chemical change. So just so you know, we will be using a material, the Alka Seltzer Tablet, that will require adult supervision for this experiment. So make sure you have a buddy with you who is an adult, a caregiver, a parent, something like that with you for the duration of this experiment. So, who here has actually seen a lava lamp before? A lava lamp is one of these guys. I tried my best to find one and I unfortunately couldn't find one in the space of the weekend. So in a lava lamp, you might notice that they get their name from the heat. And heat, in this case, is what makes these great big huge globs of liquid in here move through the other colored liquid. So the red moves through the clear, and that's why they go up and down. So heat as well as polarity and density work together to make this lava lamp work. So backing up a bit, let's talk a little bit about density. So density is when you have, it's how compactly or how tight something is packed or how tight a molecule is. So for example, you'll notice that whenever you mix together a little bit of water, and if you mix together oil with that water, so I'm using a canola oil right now. So despite me pouring them in together, you'll notice that as soon as that oil's coming in there, it doesn't actually mix. And this is because the water is more dense, so it goes to the bottom, than the oil. So with the lava lamp, these two liquids don't mix because one is more dense than the other. So that's our first concept. Our second concept is polarity. Oh, pardon me. So it's not why they don't mix together, it's why one is heavier than the other. The other concept that we're going to be talking about is polarity. Now, polarity is why oil and water don't mix. So if you're familiar with magnets, magnets have a polar north and a polar south, or a positive and a negative charge. Most molecules have either a charge or they don't have a charge. So they are polar or they are non-polar. So with water, they have a charge to them, which is why other things will mix in with the water and they'll bind and they'll be super good friends together. Whereas oil is non-polar. So if it doesn't have a charge, like oil, they won't mix together. And that's why these two stay separate and they stay on different levels. So water is more dense than oil is non-polar, and water is polar, and that's why they don't mix. So here's the very start of our experiment. So to get our experiment to actually work, we need to use a third concept that isn't present in a normal lava lamp. A normal lava lamp will use heat to make one of the liquids inside of it. So for example, the red liquid that moves up and down through the clear liquid that we saw, it uses heat to make the molecules in that liquid expand and get lighter and lighter and lighter and move up. In the case of our lava lamp, we're actually not using heat. We are going to be using a chemical reaction or a chemical change caused by an Alka Seltzer tablet. Now, the reason why this works is when an Alka Seltzer tablet makes contact with water, you can see that there is a chemical change, and it's because the water and the Alka Seltzer tablet are reacting to create carbon dioxide. So if you remember from last week, I was talking about carbon dioxide and how it makes the bread expand. Carbon dioxide will actually bond, and it sticks to the water droplets in here, so it makes them move around, and it actually makes them a little bit lighter. So that's how our experiment is going to work. So without further ado, I am going to go through my experiment. So what you do for this is you want to fill your glass with about 1 part water, to 4 parts oil. So we have a lot more oil than we have water. The measurements don't have to be exact, so don't worry if you get a little bit different from what you can see on mine. So once you have your oil and water, you can pour in your water first or your oil first. Again, it doesn't really matter because they will actually sort themselves out and separate themselves out due to their non-polar and polar non-mixy tendencies. So once you've done this, you want to add about 1, 2, 3 drops of your food coloring. It can be any color. I just happen to see I have pink and I really like pink, as you can see, so I did that. And then the next part, you can actually carefully break your Alka Seltzer tablet up into about 3 pieces, 4 pieces, or you can drop it all in at once and watch what happens. So you can see that chemical reaction starting. I'm going to drop another piece in. Okay, there's my next piece. And what do you see? So if you watch carefully, you can actually see the colored water moving up in bubbles through the oil. So I'm going to leave that here. Now keep in mind, your lava lamp will only last for as long as the Alka Seltzer tablet is still dissolving, so that chemical reaction is still happening to produce the carbon dioxide, which is going to bond to, or it's going to stick to the water droplets. So when the carbon dioxide, which is a gas, when it sticks to the water, that's when the water droplets start going up, 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 up through the oil, and you can actually see that reaction, which looks just like a lava lamp, happen. Now, we're going to mix things up a little bit. I'm going to add a bit more water to a new cup. And I'm going to add a little bit more water this time. If you want to get different results for your experiment, you can change things up a bit. And instead of using my canola oil, I'm going to use olive oil this time. And let's see if anything different happens. So we want to add in a fair bit of that olive oil. There we go. My ratio is about 1 to 2 parts there. That's okay. All right. So we have a fresh Alka Seltzer tablet here. I'm going to break this one into 4. I'm going to give this one 3 drops again. 1, 2, 3. And then let's see if this has the same reaction. Okay. So one thing that I notice is a little bit different is that there's my green. So my green is now mixing in. And if you carefully look through, you can see those green bubbles. They're now mixing and moving up. I see a couple little green bubbles. It's not quite wanting to spin as easily as I want it to. Okay, so as this is working through, I'll explain the rest of this. So how it works is when you have, the other part is when the bubbles are rising up through the oil, the reason why the water actually comes back down is because when those bubbles are the water molecules as well as the carbon dioxide bubbles rise up, as soon as they hit the surface, so they hit the air out here, the bubbles will actually dissolve. The carbon dioxide ones will dissolve and they'll just poof, and that's why the water goes back down. So you get this continuous motion of going up and then going down and then going up and then going down, and that mimics what the lava lamp does. Okay, so today we covered the concepts of density, so how compact and how tightly packed a molecule is or an item is. So in this case, water is more dense than the oil on top of it. We also talked about polarity, which is why the oil and the water don't mix together very well. They don't play very well because the oil is nonpolar and the water is polar. And we also talked about a chemical change, which happens when you use the Alka Seltzer Tablet and it comes in contact with the water to create carbon dioxide, which is what causes our lava lamp to work. So if you have any questions, please feel free to put them in the comments. I'm more than happy to answer any questions. There is a booklet of pages that will accompany this video when it's put up on Facebook, so stay tuned for that. And we're also going to be uploading all of our videos onto YouTube, so you can access them at any time if you want to use a different platform than Facebook or social media. And we'll have the link posted below for our Penticton Public Library YouTube. Thank you very much for watching, and I hope to see you guys next week.